Well, it's been a great school year. This is the very last review of the year. This is for Chapter 12. And I hope that you do well on this, our last official test before the final. Hey, what is the common ratio of the sequence of numbers here? I'm not sure that it's a common ratio. I'd have to check both of them. But if I assume it's a common ratio, basically what I'm going to be doing is taking and you know what, it might be kind of helpful to think about this. If I go 2 and then multiply by 4, I get an 8. Multiply by 4, I get a 32. So I get this common ratio by taking a term and then dividing it by the previous term. So 32 divided by 8 is the common ratio of 4. 8 divided by 2, common ratio. So I'm going to take this value 9/8 and I'm going to divide it by 3/2 to get the common ratio. So I'm looking at 9/8 times 2/3. And we can simplify that some, obviously, right? There's a common factor of 3 here, and there's a common factor of 2. So what I'm left with is 3/4. So if I was to, I can see that now that I look at it too. But if I take 2/3 and I multiply that by 3/4, I indeed do get 9/8. And if I multiply that by 3/4, I do indeed get 27/32. So if I'm looking for a geometric sequence, the hallmark is that I have to have a common ratio. I'm multiplying by a constant each time. And I can see in this first one, I go from 1/2 to 1/4 to 1/8 to 1/16. Clearly, this is geometric. And my common ratio here, r equals 1/2. I'm multiplying by 1/2 each time. For B, when I look at it, 4, and then I go to 8, 16, 32, 64. There is a common ratio there, and the common ratio is the number, it would have to be -2, right? Because I'm alternating between positive and negative. So 4 times 2, 8 times 2, 16 times 2, etc. So this is also geometric. Number C, let's see, 1 times 3 is 3, 3 times 9 is 9. 9 times 3 is not 81, right? 9 times 3 would be 27. So something happens in here, right? So this is not geometric. And that's all I have to do is specify that there's not a common ratio here. Although the first 3 terms were hopeful, we can see that fell apart. The next one, it appears that it looks like I doubled the first time, but if I doubled again, I would have to go to 60, and there's a 45 in here. What I think is happening here is I have a common ratio, right? It looks like I'm adding 15 each time. So this would be an arithmetic sequence. So this is not geometric either. So for this question, I think it was question number 2, both A and B are geometric sequences. Find the 20th term of an arithmetic sequence in which the first term is 5 and the common difference is 4. So I could start with, just the number 5, and then I could add 4 and get 9, and add 4 and get 13, etc. And I can go all the way out and finally find the 20th term. But it's probably a nice idea to go ahead and write the explicit formula for that. So remember, the explicit formula, it looks, arithmetic it's linear, so it looks something like y equals mx plus b, where this m value is my common difference. It's what I'm adding each time. And a sub 1 is my y-intercept, kind of, right? It's where I'm beginning, except I have to adjust it for a 0. So I could start with this equation, right? Y equals 4 times x plus 5. And then the one thing is this is kind of off by 1. So the one adjustment we do, if I wanted to write this in as an arithmetic sequence, I would say, hey, the nth term is equal to 4 times the quantity of n minus 1. So that's my adjustment, and then plus the number 5. So, and you can see, like, I know this is the first, the second, the third term. If I want to test it, if I plug the number 3 in there, you can see I get 3 minus 1 is 2. 2 times 4 is 8. 8 plus 5 is 13. So it does produce 13, right, when I plug in 3. And now that I've got that set up, I can say, well, what does it produce if I throw in the number 20? 20 minus 1, of course, is 19. So I've got here 4 times, I'm sorry, not times, but 4, no, actually, I'm sorry. I have 4 times the quantity of 20 minus 1, which is 19. I'll just plug those in there a second. 20 minus 1, and then plus 5. So 4 times 19 plus the number 5 is 81. So the 20th term would be the number 81. Identify the arithmetic means. I can see that this particular value right here is in between the 1 and 29. So if I was to take, for example, 1 plus 29 over 2, which of course is 30 over 2, I would get that this particular value would have to be 15. And now that I know that that's 15, right, I can then go ahead and calculate this. This arithmetic mean would have to be 1 plus 15 over 2. Of course, 16 over 2 is the number 8. And then the last value here is this one. This is the arithmetic mean here is going to be 15 plus 29. When I add 15 and 29, I believe I get 44. Oops, divided by 2. And 44 divided by 2 is the number 22. So the arithmetic means that I have here, I've got a 8, 15, and 22. And each time I'm finding, the one that's in between it, or exactly between two of the other values. Okay, so this next question is probably more simplistic than it could be. It could be worse, but it says, how many terms are there in this expansion? Now, to me, I'm the kind of person that would probably think about a few things if I'm not sure about it. So, for example, if I went from 1 to, say, 8, I know that I would have a first term, a second term, a third term, a fourth term, a fifth, a sixth, a seventh, and an eighth. And I'm like, okay, I get it, right? If I'm running from 1 to 8, there are going to be exactly 8 terms there. So when I'm running from 1 to 53, there are going to be 53 terms. So the short answer is, hey, there's 53 terms in this sequence, right? A bigger thing is like, well, what is the value of that, right? What's the sum of the terms from 1 to 53 of 29n? And in that case, you might consider this little formula here, right? This says the sum of this series is the first value plus the last value, and then you're going to divide that by 2 and multiply by the number of terms. So if I was doing that for this particular problem, right, this would equal, well, the number of terms is 53, and the first term would be the number 29, because you can see it's 1 times 29. The last term would have to be 53 times 29, and I could do that on my calculators. 53 times 29 is 1,537, and then I'm going to divide that by 2. So the sum of these values from n is 1 to n is 53, where each of the terms are 29 times n, would be 29 plus 1539, so we add 29, and then I'm going to divide that by 2, and I get 783, and I'm going to multiply that by, so this is 53 times 783, which equals, I believe, 41,499. It's a fairly large number, this grows. I mean, each time I'm just adding on an additional multiple of 29, but that should be where it's at. That's not what this question asked. I just want to kind of review that for you. What it asks is, how many terms are there, which is an important part of this question, right? You need to know how many terms there are before you can use this method to calculate the sum of all the terms. What are the 3 missing geometric means for this sequence? So we're going to go ahead and use this idea of the geometric means first, right? Geometric means. And we're going to we'll start by finding this value. This particular value is the geometric mean of 2 and 162. And of course, if I want to find the geometric mean of two numbers, it's their product, the square root of their product. So the square root of 2 times 162 is exactly 18. Now that I know the value to the left and to the right of this spot, I can use the 2 and the 18 to find its geometric mean, right? 2 times 18 is the 36, and the square root of 36 is 6. And finally, if I want to find this value, I can use, again, the values to the left and to the right. So here I'm looking at the square root of, the geometric mean is the square root of a product. So the geometric mean of the numbers 18 and 162. And that number is pretty large. The square root of it is 54. I'm out of my screen right now. Now there's another way we can attack this problem, right? And it's, if you think about this, I'm starting with the number 2 and I'm going to multiply by a particular value 1, 2, 3, 4 times. So if I was to write that out algebraically, it looks like 2 times, I'll write the value b, I'll call it b. 1, 2, 3, 4 values of b. So I've got 2 times b, and when I do that, I should get a value of 162. So this is equivalent to 2 times b to the 4th power equals 162. I don't know why that's yellow or orange. If I divide both sides by 2, I get b to the 4th equals 162 divided by, by 2 is 81. And then the 4th root of that, the 4th root of 81 is equal to 3. So b is the number 3. Now, why that's useful is if I take the first term, right, 2, and I multiply that by 3, I get 6. And if I take 6 and multiply that by 3, I get 18. And if I take 18 and multiply by 3, I get 54. And finally, 54 times 3 is 162. So that was using both the geometric mean and thinking about, you know, what it means for to have a geometric sequence. So what is the 34th term of this particular sequence, right? Now, when I look at it, I go from 9 to 6 to 3. And what's happening here is this, to me, looks like it's arithmetic. And it looks like each time I'm taking the 9 and I am subtracting 3 to get the 6. I'm taking the 6 and I am subtracting 3 to get the 3. So it looks like I have a common difference, d, that is equal to negative 3. The other thing I know is that my very first term, a sub 1, is equal to the number 9. Now, for an arithmetic sequence, right, a sub n, if I was to write this, I could write it as a linear equation first and then flip it, or I could just use the notation that our book had. It said, hey, take the very first value and add to that an n minus 1 times the common difference. And either way works, what we've done on other slides or what the book does. Here I'm just plugging in what I know, right? I know that my common difference is negative 3, so I've got an n minus 1 times the number negative 3, and my first term is a 9. So if I want to know what the 34th term is, right, I'm just going to have to place the number 34 in for n. So let me grab my calculator here. I've got 34, 34 minus 1, I think it's 33 really, and then times negative 3, of course, is negative 99. And when I take negative 99 and I 9 plus negative 99, that equals negative 90. So the 34th term would be the number negative 90.
Okay, so I find the sum of the values of a sequence that has a first term of 3. So the very first one would be 3, and then each time we're adding 1/2. So this is looking like 3, 3.5, 4, 4.5, 5, etc. And the last value in it, 17 halves, 16 halves is 8. The last value would be 8.5. So, I mean, that's what I'm, essentially I just have to add those up, right? We're looking at the sum of the values where we're starting at n is the first term. Actually, I don't know how many terms there would be, right? I know it starts at 3, but this is, what is that? Is that the 10th term, the 12th term? But each time that the sequence looks like this, right, it's going to be, let's see, my first value is 3, so it's 3 plus a 1/2 times n minus 1. So by having that n minus 1 adjustment in there, the first time it's 3 plus no halves, and then when n is 2, it's 3 plus 1 of the halves, and when when n is 3, it would be 3 plus 3 halves. So that'll take on the values 3, 3.5, 4, 4.5. But what is the, there's not that many left here. So 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5. So if I was just to count them with a handy dandy red pen, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 things that are getting added up. So I could complete this by writing just, there's 12 of them. And, grab your calculator, run through, do that numbers, add them up if you want. Just, make sure you maybe double check it. The other option that we have is this notation that was introduced in our book, right? If I want to find the sum of the values from a sequence, if I want to find a particular series, there were two of these. They gave us one of these that dealt with arithmetic sequences and one that dealt with geometric sequences. We're clearly arithmetic here. And what it says is, in order to find the sum of these, there's a handy formula for it. It says multiply by how many elements there are, and in the numerator just take the value of the first one plus the value of the last one and divide that by the number 2. And if I look at it, we have all that information, so I can just plug things in here. I've got 12 things that I'm adding up because I counted them with the red check marks. There's 12, n is 12. The first value is 3. The last value I could write as 8.5 or 17 halves. This is 8.5 divided by 2. So 8, 9, 10, 11. So I've got 11.5. So I'm just looking at 12 times 11.5 over 2. And it's 11.5 divided by 2 is 5 3/4. And if I multiply that by the number 12, I get that this adds up to 69. So the sum of those values from the 3 all the way to the 8.5, if I add them up, I should get 69.
Okay, we're asked to find the sum of the values of a series of numbers, and I believe this series is arithmetic because each time I'm going to be subtracting an additional 2 units. So for example, if I was to figure out what some of the terms are here, when k is 1, this is 50 minus 2 times 1, so the very first value is 48. The next value, k, would be 2. That's 50 minus 2 times 2, or minus 4. 50 minus 4 is 46. And when it's 3, I've got 50 minus the number 50 minus 6, which would be 44. So you can see that this is indeed decreasing by 2 each time. So I have a common difference of negative 2. Keep going down by 2. And if you look at this particular formula, right, the values, if I add up the members of this, if I find this series, right, the sum of the elements of this sequence, it's equal to how many terms am I adding up times the quotient of what's the first term plus the last term that I'm using, all divided by 2. So far we're pretty good, right? I know exactly the first term, that's 48. I know that I'm using 15 terms, it's 1 to 15. And this is the only thing that I'm not sure of yet. What's the the last term. That's pretty easy to get, right? Because the last term is going to happen when this is the number, when k is 15. So I can come over here and I can figure out like dot, 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 dot. The last one is going to be when I've got 50 minus 2 times 15, or 50 minus 30, which is the number 20. So we're going to end at 20. So I have everything that I need to pretty quickly find the value of this this series. So there's 15 terms, and I'm going to multiply it times 48 plus 20, all divided by 2. 48 plus, where's my calculator at? 48, why do arithmetic when I can push buttons? 48 plus 20, and I'm going to take half of that. Yeah, which is 34. So I'm looking at 15 times 34, which is 510. 15 times 34 equals 510. So I believe that the sum of the first 15 values of this arithmetic sequence is the number 510. Find the sixth term of the geometric sequence for which a sub 1 equals 4 and r is the number 3. And this is, I'm told, geometric. So we're going to go ahead and look at a sub n, right? The nth term is equal to the first term times my common ratio raised to the n minus 1 power. Well, my first, for this particular problem, right, and I want the sixth term. The first term, I'm told, is the number 4. My common ratio is 3. I'm multiplying by 3 each time. And I'm going to raise that to the 6 minus 1, or the 5th power. So 4 times 3 to the 5th equals the number 972. And of course, you know, it wouldn't take that long, right? If I take the number 4 as my first value, and then I multiply that by 3, and I get the number 12, and then multiply the 12 times the 3, and I get the 36, and then I take the 36, and I multiply that by 3, and I get 108, and I multiply that by 3, and I have 324, and if I multiply that times 3, I get 972. So you can see the first, second, third, fourth, fifth, and here's the sixth term. So the answer is 972.
So we're going to find the value of this particular series, and there's only 4 elements that are getting added together. K will take on the following values. K will equal the number, and I'll make a little table. K will equal 1. K will take on the value 2, 3, and then the last value of K is 4. So we see that from the indices. Remember, this tells me where K starts, and this says where K is going to end. And each time the expression that we're evaluating to figure out what that particular element is in the sequence is going to be 3 times 2 raised to the k minus 1 power. The very first time we're in here, k equals 1. So we're ended up with 3 times 2 to the 0 power. And I'll just write it 3 times 2 to the 0 power because k, 1 minus 1 is 0, which is 3, right? 2 to the 0 power is 1. So we've got a 3 for our first term. The second term, k is taking on the value of 2, so I have 3 times 2 to the first power, which is 6. The next one we've got k is equal to 3, so that's going to be 3 times 2 squared, not to the 4th. 3 times 2 squared, which is terrible looking. You know, I'll erase that. You won't even see it looking bad. You'll just see the final one. 3 times 2 squared, which is 3 times 4, 12. I just say it's 12. And you know, really, honestly, at this point, I can see each time I'm multiplying by an additional 2. Right? So the last one's going to be 24, which is 3 times 2 to the third. 3 times 8 is 24. So what we're looking at here is the sum of the values 3 plus 6 plus 12 plus 24. This is definitely a finite series because it's just going from 1 to 4. And it's the sum of those values. 3 plus 6 is a 9. 12 and 24 is 36. I'm just chunking those together. And when I add them, I get the number 45. So that particular series from 1 to 4 adds up to 45.